Hi, Integrated Math 1. Welcome to lesson E.1-5B, where we're talking about compound inequalities. And we're on our second day of talking about compound inequalities. Last time we were looking at the graphs of compound inequalities and how to write them. We know compound inequalities have two or possibly more inequalities in them. That's what makes them compound inequalities. We talked about how some of them have or and some of them have and. We also actually solved some or inequalities last time, didn't we? Today, let's solve an and compound inequality, shall we? So here we have example 3 on page 32. And we are asked, what is the solution of negative 12 is less than or equal to 7x plus 9 is less than 16? Now, because I see it's all squished together like that, that tells me that this is an and compound inequality. So the fact that I see it all smushed together, right, there's two of them over here, this tells me that this is an and compound inequality. It's not an or. But I still need to solve it, right? I still have two inequalities here I need to solve. So let's solve the first one, which is this side. Negative 12 is less than or equal to 7x plus 9. So I'm going to go ahead and solve that one. Negative 12 is less than or equal to 7x plus 9. That looks to me like I need to get my x alone. I should subtract the 9. I'm going to go ahead and subtract 9 on both sides to make those cancel out. Of course, negative 12 minus 9 is a negative 21, which is less than or equal to 7x. I do need to divide both sides by 7. Because I am dividing both sides by a positive, I don't need to flip my inequality. We're going to keep it right where it is. And of course, these 7s cancel out, right? That's why we did this. Bye. And negative 21 divided by 7 is a negative 3. But there's a second inequality here, so let me just grab a different color so you can see it. My other inequality is this side, right? Where I take the middle with the right side. So my other inequality is negative 7x plus 9 is less than 16. So that's my second inequality. And again, in order to get the 7x alone, I am going to go ahead and subtract by 9 on both sides, so that these will cancel out. And 16 minus 9 does give me 7. I'll divide both sides by 7. Since I'm dividing by a positive, there is no need to flip the inequality. We'll just leave it. And of course, these cancel out, which means 7 divided by 7 is 1. So x is less than 1. All right. Now this is an and situation, so it's a little bit different than what we did before. So if I were to graph each one of these, so if I were to graph this one, I would do a closed circle at negative 3. X is the bigger guy, right? Alligator eats the bigger one. X is the bigger one. So that means I need to color to the right. So I colored to the right. So closed circle at negative 3, I'm coloring off to the right. For this one, we're going to do an open circle at 1. And it says that X is the smaller guy here, so I need to color to the left. All right, now, with the ors, we just shoved them together and included everything. And is a little different. With the ands, what happens is when we collapse them together, we're just looking for where they overlap. Okay, so if I have my number line, and I want to make sure I can see negative 3. My pen is being weird today. Sorry. So I want to make sure I can see negative 3, and then negative 2, negative 1, 0, 1. I want to make sure I can see my 1, right? And of course, we have other numbers. But I want to make sure I can see those guys. So here's the deal. Closed circle at 3, and we're going to color to the right. Open circle at 1, color to the left, and you can see they meet up in the middle. So what's happened this time is I don't want to go past negative 3 because x has to be greater than negative 3. I don't want to go past that. I don't want to go past the positive 1. X has to be less than 1. So when I combine these two, I'm looking for where they overlap. So when I see and, that means I'm looking for where they overlap. Okay? With that in mind, hang on, let me show you the pretty one. I'm gonna show you the pretty one. So you got the idea from this, but I wanna show you the pretty typed one. Erase that out of the way. There's my and. You can erase that too then. So the final graph is all of the points that appear in both solutions. It has to be true for both of them. So I'm just looking for where these two graphs, if I put them right on top of each other, where would they overlap? That is my and. And thus, we can either write our solution as x is greater than or equal to -3 and x is less than 1, or you can write the collapsed version, right, the squished together version, where we say -3 is less than or equal to x, which is less than 1. Either way of writing the answer is correct. So, with this in mind, I would like you to do the try it problem. Number 3, just below example 3 on page 32, I would like you to solve the compound inequality. -2 times the quantity x plus 1 is less than 4, and 4x plus 1 is less than or equal to -3. Don't forget to graph your solution. Go ahead and hit pause to work this out. Hit play when you're ready to check your work. So let's just start with the first inequality, right? I'll start with this one. And of course, I'm going to start by distributing that -2. -2 times x is -2x. -2 times 1 is a -2. Oh, I want to get rid of that -2. I'm trying to get the x alone. So I'm going to add 2 to both sides. That feels like a wise decision to cancel those out. And of course, 4 plus 2 is 6. I do need to divide both sides by a -2, and because I'm dividing by a negative, we're gonna flip that inequality. Instead of less than, it becomes greater than. Of course, the reason we divide by -2 is to make those cancel out, and 6 divided by a -2 is a -3. So x is greater than -3. Awesome. Here's our other one. So let's solve the second one, right? Compound inequality. I got 2 I gotta solve, 2 for the price of 1, right? So let's solve this one. I'll go ahead and subtract 1 from both sides to make those cancel out. -3 minus 1 is a -4. I'll go ahead and divide both sides by 4. Because it's positive, I don't need to flip the inequality, so those are gone. And of course, -4 divided by 4 is a -1. So x is less than or equal to -1. Now, let's graph this bad boy. You ready? We're going to graph it. Because this is an and situation, right? This is an and situation. So I do want to make sure I can see -3 on my graph. -3, -2, no, and -1. I need to make sure I can see both of those, right? Those are the important numbers here. So I can see -3, I can see -1. All right. X is greater than -3, so that means an open circle. If x is the bigger guy, I got to color off to the right. I'll finish coloring in a minute. X is less than or equal to -1, so fine, close circle at -1. And x is less than, x is smaller than that, so I need to color off to the left. Oh, and sure enough, they meet up here in the middle. So we can either say that our answer is x is greater than -3 and x is less than or equal to -1. That's one way of writing it. But we also said that it's okay to do the collapsed version if you like. I'm going from -3 to 1, so -3 to 1, x is in the middle, a couple of less than signs. Oh, and it is closed at -1, so I'm going to, forgot my negative, I'm going to put a little squashed equal sign there. Either way of writing this is totally correct. I'm happy to take either one. You can write it either way. Here, I'm going to show you the pretty version. Pardon me. Let me show you the pretty typed up version when you erase all this ink. There we go. There it is, all pretty. That's so pretty. So I do have one more example and try it problem just to play with a little bit. Just how can we apply this in the real world? Now, my cat, Charlotte, I adore her, but food is not her love language. It's just not. So the deal is I can put food out for her and she'll eat it when she gets hungry. But I know that the dog I grew up with was not that way. My dog that we grew up with, you put that food out and he ate it all. It was gone. So it became important to watch what we were feeding him because, dude, you put down food and he just ate it. It was gone. So Enrique has discovered this problem. And Enrique plans a diet for his dog, River. Is the dog's last name Song? I'm not sure. So River consumes between 510 and 500 calories per day. And we're trying to keep River within that limit. So here's the deal. If River eats 1.5 servings of dog food each day, how many treats can she have? Well, I see that a serving of dog food is 320 calories, and she's getting 1.5 of those each day. And I can also see that her treats are 15 calories each. And we want to keep her between 510 and 540. So let's do some adjusting, shall we? Let's set up an equation. So I'm going to let X represent the number of treats River can have each day. So we're going to say X is the number of treats she gets. So I know that she's doing 1.5 servings of the 320 calories. Plus, she's also getting X number of treats at 15 calories per treat. So let's see if we can make an expression out of this. Well, first of all, I can do this part, right? 1.5, 1.5 times that 320 calories. And if I grab a calculator real quick, I can be like, okay, 1.5 times 320. And I can see that just her dog food is 480 calories. But we're adding on X number of treats, 15 calories each. So we're adding on 15X calories. Now, remember, we're trying to be between 510 and 540, right? You don't want to feed your dog too little. Depending on the dog, they got a lot of energy to burn, right? You don't want to feed them too much because we're trying to keep them in a healthy weight range. So we want to feed River at least 510 calories and at most 540 calories. But we don't want to go under 510 and we don't want to go over 540. This sounds like an and inequality, compound inequality, right? I want it to be 510 at the lowest. So I want to be 510 is less than or equal to 480 plus 515x. But I want it to be 540 at the most. So I'm going to say less than or equal to 540. And now that we have this, we can solve it. Now, last time when we solved our compound inequality, we broke it up into two. But can I show you? I'm going to show you. You can actually, on these compact ones, you can do it all in one go. You remember the rule, what you do to one side, you must do to the other? That still applies here, only now I've got the middle, the left side, and the right side. I can do this. So if I want to get X alone, watch, this is so cool. I'm going to subtract 480. But if I subtract it in the middle, I also need to subtract 480 on the left, and I need to subtract 480 on the right. So I'm going to do 510 minus 480, 480 minus 480 plus 15x, and 540 minus 480. Did you catch that? This is cool because it means I could just, instead of doing two separate inequalities to solve, I'm just going to do it all in one. So of course we did that so that these will cancel out. 510 minus 480 is 30. I still have a 15x inside, and we have 540 minus 480, which is 60. Wow, that knocked out a bunch of stuff. And I need to get the x alone, so you know the deal. I'm going to divide by 15, but if I'm going to divide the middle by 15, I also have to divide the left side by 15 and the right side by 15. Everybody gets divided by 15. We do that so that these will cancel out, and then this simplifies down quite nicely. 30 divided by 15 is 2, and 60 divided by 15 is 4. So 2 is less than or equal to x is less than or equal to 4. So it looks like River can have somewhere between 2 and 4 treats each day. So River can have at least 2 treats and at most 4 treats a day. So, River should be getting at least 2 treats a day. It's important to give your dog treats. I don't mean that they won't love you if you don't. I'm just saying, be good to your dog. But you know what? as Enrique's planning this diet, he finds some new treats. So again, River is still consuming between 510, 540 calories a day. River's still eating 1.5 servings of dog food each day, but we found new treats. So River's new treats that are only 10 calories each. Fortunately, dogs can't count calories, so River probably doesn't know that these are lower calorie treats. How many of the new treats can she have and remain within her calorie range? Go ahead, hit pause to work this out, and then hit play when you're ready to check your work. So we're still going from 510 to 540, where she's still eating 480 calories worth of dog food, but now instead of 15 calories per treat, it's now 10 calories per treat, which means we're really doing a lot of the same stuff we did before. So let's go ahead and let's do this then. I want to get rid of the 480, so I'm not only going to subtract it in the middle, I will subtract it on the left and on the right. Of course, those go away. That's why we did it. We already know 510 minus 480. And we also already know 580 minus 480 because we did those before. So we know 580 minus 410 is 30. These canceled and I have a 10x. 540 minus 480 is 60. Just like last time, we're going to divide to finish it off. I need to divide by 10, not only in the middle, but also on the left and the right. So everybody's going to get divided by 10. So those will cancel out. And of course, 30 divided by 10 is 3, and 60 divided by 10 is 6. So it looks like River can have at least 3 treats a day and at most 6 treats each day. So River doesn't know that they're low calorie because she's a dog, but you look like the hero because you're giving your dog more treats. Clever, right? Clever. As always, guys, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, come talk to me, and I'll see you guys later. Bye.